Well, thank you very much for this kind introduction. I'd like to add my comments to those of Deborah and Al in congratulating you going through a very rigorous process here through the National Academy of Engineering. It's very nice to see faces behind the nominations. And welcome to FOEE, to NAE, and sunny and pretty California as well, especially for those of us who come from much colder parts of the country. I'd like to thank all the organizers and all the speakers. The first ones being Jonathan Jaglom and Anthony Moschella from MakerBot as keynote speakers. MakerBot, a subsidiary of Stratasys, is the next industrial revolution with reliable and affordable desktop 3D printing. So in our various universities, we are all familiar with 3D printing. We all have those in our machine shops and makerspace, perhaps. But really what MakerBot is doing and has been doing is really making those tools reliable and affordable so that we can add those to our desktop tools. And for a lot of us who are in academia, we like awards and prizes, but it turns out that industry and companies like MakerBot also receive a lot of prizes, and certainly MakerBot has been receiving many accolades, including Time Magazine's Best Inventions of 2012, Popular Science Product of the Year, Fast Company's one of the world's top 10 most innovative companies in consumer electronics, etc. So they are really offering a disruptive technology which has the potential to revolutionize the way we do manufacturing in this country, in the world, but also the way we do engineering education. And I hope that both Jonathan and Anthony will be able to answer some of the questions. Jonathan Jaglom, as CEO since February 2015, oversees the corporation direction and strategy for MakerBot's global operations, including sales, marketing, technology, and products. Prior to this, Jonathan worked for MakerBot's parent company, Stratasys, and he had various roles there, including general manager of Stratasys in Asia, where he oversaw a successful distribution model across many countries and added the market in Singapore, Korea, Beijing, and India. And prior to this, he worked for the company called Object since 2005, which also merged with Stratasys in 2012. And there he also had a lot of different roles, including regional manager of East Europe and VP of Global Sales Operations. And finally, he received a bachelor's degree from Tel Aviv University in the humanities. We'll forgive him for not being an engineer. And an MBA from Northwestern. Anthony Moschella is VP of Product at MakerBot, where he works with MakerBot's team of engineers to design tools for the manufacturers and creators of tomorrow. A passionate engineer, Anthony works to help bring the disruptive technology of desktop 3D printing to the masses and brings more than a decade of consumer product design experience. Before joining MakerBot in 2012, Anthony developed ultra-low power wireless sensors, high-performance automotive simulation tools, and embedded robotic systems, for which he was awarded multiple patents. Anthony is a true engineer, not only in what he does today, but he also received a BS in electrical engineering from Brown and an MS in computer engineering from Georgia Tech. Unfortunately, Anthony and Jonathan could not be here in person, but they're going to use technology to be with us today through a video, and we'll see whether technology is as powerful as we say it is as
We have
engineers.
45 minutes, I understand. 25 minutes of presentation, around 20 minutes. My name is Jonathan. Here to my left is Anthony.
Hello.
Anthony's leading the products, and I'm the CEO of MakerBot. So we'll quickly go through this deck of slides that we had prepared for the event. Just a very brief overview about MakerBot. MakerBot is the leading player in what is dubbed the desktop 3D printing space. It's a space that is represented from a price point of roughly $5,000 or below, and really allowing for mass accessibility to 3D printing, the likes of which was never done before. It's a relatively young company, set up in 2009, and have been very, very successful in this space. We have an install base of about 100,000 printers, and we are also very much in a world of what we call ecosystem surrounding our printers. These are software and hardware components surrounding the printers that allow for greater accessibility and empowering of the individual. Whether it's Thingiverse here that you have in the back end of this right-hand snapshot. Thingiverse has 1 million downloadable 3D files online, has a community of above 500,000 active users, and is by far the biggest platform for 3D printing on the internet. So MakerBot, just to wrap this up, because there's a lot we can talk about on this slide, but just to wrap up, it's important that everyone understands that MakerBot is not only a hardware company, but very much also a software company surrounding ecosystem to the printers in question. And really coming back to our core purpose, our core role is to enable creativity. Whatever we do, whatever products we bring to market, is really around empowering the individual through our technology, through our solutions, to be as innovative and as creative as possible. And that is exactly why we also offer an entire experience around our printers and not just the printers themselves. So I'll let Anthony quickly explain how 3D printing fits into the design cycle, and then I will continue with some examples.
Thank you, Jonathan. So I think, to echo Jonathan's point, the most important thing that MakerBot does is it really brings accessibility to 3D printing. And for you in your industry, or in the academic space, the accessibility is really key to changing the way people think about traditional prototyping and think about product development design, education of design. And if there's one thing that we can really take from this, is that 3D printing is becoming very much a real mainstream technology. We have one of our largest segments is the education space, and it's amazing to me, and Jonathan will talk about this later, is what kind of traction we're getting in the K through 12 space. But what really is happening here is it's a change in the way people are fundamentally designing things. And this is happening in industry, it's happening in academia, and it's happening in K through 12. As the previous speaker talked a little about engineering tools for traditional physics professors or chemistry teachers or people who don't necessarily have an engineering background, science teachers. And I think MakerBot really fits into this. So where this is coming from is on the professional side, where there's historically been this very linear development process. A concept, then a prototype design phase, send out for parts, send out for machine tools, get back, evaluate. And the cycle is linear. It's slower, and it's ultimately not representative of the future of manufacturing and design. So the idea that MakerBot injects into this is having prototyping, very meaningful prototyping capabilities at your desktop, at your fingertips. So for the engineer who's developing an idea, they can iterate on that idea not in weeks or months, but in hours. And we see this at MakerBot constantly, where every engineer, every developer has a MakerBot on their desk, and prototyping is a fundamental part of the way we work. So the end result is that an engineer will prototype 10, 15, 100 times in their own space at very low cost and get a better product to market quickly. So that repetition, that exploration, that tangible evaluation of your designs is a very meaningful part of the manufacturing cycle, but it's also a very meaningful part of the education cycle. So if you imagine a classroom, that ability to realize an idea for a student is very powerful. It's empowering. It's exciting. And it's not just a matter of being able to take something home and show your parents. It's the idea of that the work that you do in the classroom can become real. And if we're taking this idea and taking this work from the K-12 space into an engineering curriculum at universities, this is what's going to drive the next generation of engineers. The idea that your ideas can become real, whether it's software or hardware, and 3D printing is essential. So this slide kind of shows the repetitive cycle of design evaluation and kind of that tangibility of prototyping. And what 3D printing in your desktop and in the classroom does is it really just shortcuts that whole workflow. So we've seen this happen time and time again with our professional customers, and that same idea trickles down into the education space. So Jonathan's going to talk about a few of our key customers.
Yeah, just to add on to that from what was just shown with Anthony's slides. So it's very interesting because Anthony and I complement each other, I think, in many ways in terms of the industry. I've been with the industry for 10 years, so I definitely saw when I walked into the industry, a product was selling for about $250, actually more like $150,000 to $200,000 was the average selling price of the products in question. And Anthony sort of stepped in right in the beginning where MakerBot was established as a highly disruptive product that was at a much, much lower price point. And the differences that we are seeing is that in the world of product development, iteration and cycle and product development are happening a lot faster than ever before. Now, it's a question of, is that because of the technology that has been brought to the equation, such as 3D printing, that is allowing for that pace to grow, or did the design cycle require it and the technology came in later? That's philosophical. We can have that discussion. But definitely what we're seeing today, and again, I have sort of 10 years of experience to rest on, is that when we go to visit customers, their need for a prototype is faster than ever before, definitely faster than 10 years ago. And having that desktop 3D printing beside the engineer, beside the designer is extremely beneficial to speed up that pace, and that's what Anthony was discussing. Mishimoto is a customer of ours in the automotive space. It's a great example of a customer, by the way, that has two technologies. Both are Stratasys. They have a MakerBot Z18, which is our largest platform, but they also have a Stratasys Uprint printer. I went to visit this company a few weeks back, and it's very interesting to see how they use 3D printing for the purposes of designing aftermarket cooling products for aftermarket fitting of engine components. And so what you see here, I don't know if it's too clear to see, but you can see that wooden prototype, and on the edge of that wooden prototype are part of the canals of for the cooling vents of this radiator in this case, and those were printed on MakerBot printers. And what's interesting here is, obviously, as part of being in the aftermarket world, they do not have access to CAD drawings to assess whether or not their components will fit into the block engine. So what they do is they actually prototype, and the application in question here is called fit testing. In the world of 3D printing, we call it fit testing, but it's a very straightforward test, but it provides tremendous value to them, because imagine if you had to tool this and ultimately find out that it just doesn't fit as per expected. So what they're doing is really doing some fit and assembly testing prior to manufacturing the components in question. Oops, sorry. General Electric, First Build is another, it's an innovation incubator as part of GE. I also went to visit this company. They have a great motto. They say one One prototype speaks 1,000 pictures, 1,000 photos is what they're calling 3D printing. They are doing something really interesting as part of First Build in GE. They have a goal to have 12 projects launched per year, of which their target is 3 actually make it to traditional manufacturing at GE. Anything above, I believe the mark is 25 million in terms of feasibility of sale, makes it interesting for GE. Obviously, they're a massive company. They can allow themselves to have those sort of figures. But what they're doing is they're doing 3 things under one rooftop, which I find really fascinating, and honestly, to me, is sort of where potentially the future will end up being. Under one rooftop, they have design, manufacture, and sell in one space. So they're not only designing future needs, they're also manufacturing those needs, typically using 3D printing. Some of that is MakerBot, but also very high-end Stratasys equipment. And finally, they're also selling to see feasibility of needs of the product in question. And once they see traction there, they bring it to GE. The way they are handling that and the way they are addressing the product cycle in such a disruptive way, the benefit of that, they claim, is about a 2-year decline or reduction in design time on GE once that product is launched in a traditional way. So in terms of time to market, they save on roughly 2 years worth of time, which is a huge benefit. I'll quickly jump into education, as Anthony spoke about this, and obviously in the educational space, we are playing a very important role at MakerBot. We see ourselves very close to that tipping point where we will witness mass adoption of 3D printing at schools. We have already 3D MakerBot printers in over 5,000 schools across the nation. And we believe we're really close to that traction where that tipping point where again the remaining audience across the nation will embrace 3D printing and embrace MakerBot. Interestingly enough, in terms of this industry, MakerBot is synonymous with 3D printing, and so what we're having is this wonderful phenomenon that people ask for a MakerBot. They're not asking for a 3D printer. So we're definitely enjoying the hard work put in place to introduce 3D printing to the sector. The rationale behind it is twofold. First of all, we believe that by bringing 3D printers to classrooms, we allow for that future workforce to be more creative and more innovative than ever before. There's a great case study coming up at the Whitney School. It's a private school in Connecticut. But when you speak with Leslie, the teacher at the Whitby School, she embraces 3D printing and she's embracing MakerBot, not because she's expecting all her students to be engineers down the road, and forgive me for not being one, as was commented before, but I think after 10 years in this industry, I think you get half a degree in engineering after 10 years, I think is a fair claim. But anyway, back to Leslie. She is introducing 3D printing to her students and giving them some really interesting courses in 3D printing and in product development through trial and error, because they are learning the hard way, and by doing that, they enhance their creativity and their ability to innovate. And so regardless where you end up in your professional career, that has tremendous benefits to it. Additionally, of course, the idea that if you educate your future workforce, that future workforce will ultimately take that technology to where they are heading, either if it's in their working environment or in their homes. And so addressing the educational market from that perspective also makes good sense. We're definitely seeing traction in more sort of the colleges, the universities, graduates from faculties of engineering that are then taking this technology with them to their workplaces. It's sort of second nature to them, and they honestly can't really do without. We have a lot of testimonials of students that graduate and go to work areas that don't have 3D printing in-house, and they really struggle, and there's a need. It's not a nice to have. It's a necessity for them to work efficiently and effectively. So back to the Whitney School, it's a great example. What I find fascinating in this school, that's Leslie back in the background, is that you have 8-year-olds that are designing in Tinkercad and printing on MakerBot, and you have 12-year-olds that actually have assignments in product development. And so the cycle that Anthony showed before in terms of product development is the same cycle that I'm sure everyone is very familiar with in dealing with product development. It's definitely a cycle I've seen throughout my hundreds of visits in companies across the years, throughout the years. But these students, these 12-year-olds are doing exactly the same thing. They are given assignments. It's about a 2-3 month assignment where they have to do research on a given product. They have to design the product. They have to print the product. They have to test it, ultimately iterate it and optimize it as a final project to be shown to the rest of the class, and obviously also tested. The one product that I saw when I visited the Whitby School was a bobsledge. The students were asked to design a bobsledge that can carry a weight of 4 AAA batteries, and that's the load. And so they came up with their first designs, and then they went back and they found out that the load wasn't, the center of gravity wasn't correct, and the sledge wasn't sliding down as fast as it should. And they were designing it and iterating it finally to have the perfect match. Now again, these are not students that ultimately, some of them will be engineers, some of them won't, obviously, but in terms of enhancing creativity, enhancing innovation, it's tremendously powerful. And so at MakerBot, what we offer is not only the printers themselves, but also the ecosystem around it. In the case of education, we have very interesting solutions to make it 3D printing as accessible as possible, whether it's on Thingiverse, whether it's through the mobile apps that we have as part of our solution offering. Just having that accessibility to even 8-year-olds to print using MakerBot technology. Quickly about the innovation centers, we're seeing a lot of very interesting traction in this space. The MakerBot Innovation Center, it's sort of the analogy of the desktop computer labs in the mid-'80s. I always joke when I see this snapshot because it really looks identical to the one that I had in my high school. Those radiators are exactly the same. It's where when it used to snow, you used to put the gloves on that so it heats up by the next break. I used to live in Switzerland at the time. So obviously today, the MakerBot Innovation Centers that you see on the right is sort of the parallel that we see. We provide a very interesting solution for typically colleges, universities to have that accessibility of 3D printing that has never been witnessed before, all connected, so you can launch your print from your dorm, from another faculty, and you'd have these printers typically racked in a formation of 50 printers, 70 printers, and really allow for students to come and print whatever they wish in terms of their needs for their courses. Typically, the innovation centers are run by student faculty, different members that decide to run the innovation center itself. And again, coming from Stratasys, one of the great things that we see with the innovation center is that accessibility in terms of ease of use and in terms of cost. At Stratasys, when we were pushing for high-end 3D printing equipment, the cost of ownership is high, and so what we typically saw was only students in end-of-year projects or students doing their masters or even more research were using our equipment and not the remaining mass audiences of the student body. With 3D printing using MakerBot, that's a whole different story because it's a tenth of the price, if not more, and really price here becomes somewhat insignificant, and so definitely allows for students to just print whatever they desire, whatever they need, and it's all a question of that accessibility and just having that printer available for them, and then off they go and they launch a print. So definitely a tremendous benefit to universities and colleges, and we're seeing a lot of traction here as well. Anthony, do you want to add something on this one?
I mean, I think the most important thing about the Innovation Center is really that it's being used not just in engineering curriculum, but it's being used cross-functionally. Right. So at SUNY New Paltz, we've got an Innovation Center installed of about 50 machines, and the administration there chose to really make it not just for the engineering students. So they've got a big jewelry program there. The archaeology school uses them. And the Innovation Center has become this kind of hub of cross-functional idea exchange, which I think is a really exciting thing to kind of capture. Right. That 3D printing is not just an engineering tool, it's an education tool more broadly. Right.
And I'll chime into that because I've also visited these guys at SUNY New Paltz. What I found fascinating about SUNY New Paltz, turns out that in the Hudson Valley area, there's a lot of entrepreneurship. And a lot of them are farmers, and again, this is coming from my visits there. And they're offering, SUNY New Paltz as part of its Innovation Center is also offering services of printed parts.
Right.
And so what's happening is that there's a very, very interesting exchange of needs. You have quite a lot of entrepreneurs, farmers, again, is typically the case, that have a lot of expertise and they know what they need, but they have tremendous challenges in designing and getting those needs to fulfilling on those needs. And the other side of the equation, you have these students that know about the technology, that have training and can print things, but they have a lot less experience in the needs and the realities of the real world. And so having that exchange between the students that have the experience, have the expertise, but lack the know-how, and vice versa, is tremendously powerful. And to cap that up, now 1 year into this program, 1.5 years into this program, SUNY New Paltz actually has curriculums that forces students to go look and find entrepreneurs as part of their projects. So they have to find that entrepreneur, they have to satisfy that person's needs, and ultimately come up with a solution to satisfy that small business. So definitely really interesting exchange. And I think, from my perspective, I say in all humility, as a CEO, or Anthony, I'm sure as a VP of product, if we had to interview two potential engineers, one that has theoretical experience and one that has theoretical experience coupled with some practical solution finding, that has tremendous power to it. And SUNY New Paltz is doing exactly that through 3D printing, through the innovation centers, and definitely for us, it's great.
So
yeah, you want to...
Let me close and kind of tie it all together here. Is that the MakerBot product offering and how we fit into education is not just a 3D printer. It's a whole system of software and tools and content and education that makes the whole thing come together. So offering a 3D printer and putting it in a classroom or even at a university gets you so far. But it's really an ecosystem of connected products and training and materials and concepts and Thingiverse and all of these web and mobile tools together that enhance the experience in a really profound way. So to go back to that example of the physics teacher who now is an engineering teacher, MakerBot can offer a really sophisticated curriculum that gets these places up and running quickly and makes them real engineering curriculums in a very short period of time with very simple and accessible tools. And that concept starts in elementary school, goes into the academic space in the universities, and even enters into the professional space where a lot of places are not used to using additive manufacturing. We offer tools that make it so easy and so integrated into how people work.
And I think you're a great example to that, to wrap that up. As MakerBot, we use MakerBot for product development.
Constantly.
And we also have Fortis high-end Stratasys for more developed, more advanced needs.
I've been an entrepreneur in the entrepreneurial space, the small startup space, for now 6 or 7 years, and it's hard for me to imagine doing the work that we do without 3D printing on the desk.
Sure.
It's almost impossible. So
Well, thank you very, very much for this very inspiring talk. This is very disruptive technology, which has a great potential to not only disrupt the way we do engineering, but across many functions in industry and in education. The first question, which was just given to me, is where do you envision the MakerBot innovation in 10, 20 years? Will it be the computer lab of 1985 when we get to 2025? And what is the most needed component to improve MakerBot movement?
Great question.
You want to field it? Do you want me to field it?
I'll let Anthony start, and then I'll give you my...
Okay,
sorry,
yeah.
do I need to read again?
No, I got it.
No, we have the question clear.
Where's 3D printing going to be in 15 years, 10 years?
Where will we be in 15 years?
Good question. I think this industry really is in its infancy, and we haven't even hit the kind of steep part of the technology growth curve for 3D printing right now. I think in the desktop space, we're the beneficiaries of the trickle-down of some of the stuff that's coming from the higher-end systems. And there's a lot of research coming from Stratasys and others in academia of where this is going next. Materials is a huge piece of it. Speed is a huge piece of it. And I think the part where MakerBot's going to have the biggest impact is ease of use and accessibility. So I think the work that we do at MakerBot drives an easier-to-use workflow, a more accessible product, something that's tied into very mainstream systems, the web, handsets, low-end CAD. And at the high end, Stratasys and others are driving down materials, speed, fundamental technologies that are going to enable 3D printing to become more mainstream. But what I see in the not-too-distant future is large, complex, multi-material assemblies being printed in one build. We're seeing that already today. We're seeing a lot more in the functional materials space, ceramics, metals, advanced polymers. On the speed side, we're seeing massive speed improvements. And I think to answer the second part of the question, what can MakerBot be doing to drive this forward and drive this adoption is really ease of use and reliability. So those two very simple things, and that's really the focus of my team, is making printers that are easy to use for everyone at every skill level and reliable enough to fit into an education and engineering workflow.
Yeah, I will tap it. I will address it from a potential standpoint. As I mentioned in the presentation, we are in over 5,000 schools across this nation alone, and that's about 5% or less of the total amount of institutions, addressable audiences in this nation alone. So obviously, if you look at it from a EDU, from an educational standpoint, definitely there's a lot of potential for growth there. If we're roughly at 5%, then there's a lot of work to be done still. So that's one segment which is massive, the educational segment. And then you have the professional segment for prototyping purposes, as we alluded to before in terms of product design. It's a very, very difficult number to assess, but the question that needs to be asked, or one very interesting indicator, is how many 3D CAD seats do you have relative to how many printers you have to address that audience. And so we believe that we have a ratio today. Again, this is very tricky to do research on because CAD seats also include 2D, which doesn't benefit our needs. So in the 3D space, we assess the ratio to be conservatively about 1 to 50, 1 to 60. It could even go as low as 1 to 30, 1 to 40. But the research that we did about a year and a half ago suggested about 1 to 50. And then obviously that creates tremendous opportunity because what is the saturation point in that ratio? So we believe it's about 1 to 5, 1 to 7, maybe 1 to 10. Again, 10 engineers or 7 engineers for every printer. And whatever you believe that to be the case, we're definitely not there yet. So there's tremendous traction still there as well. And then for professional space in the manufacturing usage of 3D printing is absolutely in its infancy. It's really at the earliest possible days. You know, I always joke when I see things in the prototyping space, I sort of rest on my history and say the rapid manufacturing today is where rapid prototyping was about 10 years ago. Definitely there's a lot of room to grow in that space. Recently, Stratasys did a collaboration with Airbus to build 1,000 parts internally in the Airbus A350, and that's deemed a pilot for Airbus. So that's just one plane of their entire fleet, and it's a pilot of only for them. For us, it's massive, 1,000 parts to be fitted internally that are all 3D printed. Obviously, all are FAA approved, and everything is certified, of course. But imagine if that's just one plane for pilot. Imagine if you were to do that with more planes in the Airbus fleet. Imagine if Boeing decides to do something similar, and imagine other industries that would step into manufacturing using 3D printing, and that's huge, really, really huge.
Thank you. We
and
have
lastly,
to move.
we don't.
Yeah, I think we have to move to another question. I'm collecting a lot of questions here, unless you want to finish your sentence.
Quickly. Last phase is the consumer market. I'm sorry, I'll answer more quickly in the next question. The consumer market that we didn't even talk about, that, you know, the idea of having a printer in every home, which I'm a believer in, and so is Anthony, and I fully agree with what Anthony said. It has to be a more seamless process. Reliability is key, materials are key, and we're working on all those fronts. So from all those perspectives, 3D printing is very, very exciting and will be around and will grow tremendously in the future to come. And I'm sorry for that long answer. Go ahead.
Okay,
for the next
thank you very much. Second question, as makerspaces become increasingly more popular, what other type of technology do you suggest for student makerspaces that complement or add to the power of 3D printing by MakerBot?
So I'll answer this one. I think the primary complementary technology is low-cost or easy-to-use CAD seats. So things like Tinkercad is exciting, but it's pretty limited still. And I think we're going to be seeing a kind of an upswing, a groundswell of simple-to-use modeling tools that are CAD-based and also not CAD-based. I think there's a lot of room for non-CAD 3D model creation tools, parametric tools, more sculptural tools. And I think getting good software tools for creation is essential. And then complementary to that, the other part of it is everything else in your product. So simple-to-use electronics prototyping tools. A lot of these things are already starting to come into the mainstream. Simple-to-use software prototyping tools, things like Arduino and Raspberry Pi have been really helpful there. So it's really piecing all of those things together and creating an ecosystem that supports it.
Thank you.
I'll be quiet for this one.
Third question, is there an effort to standardize 3D printing, the 3D printing ecosystem, design, scanning, etc., and what role is MakerBot playing in this?
Standards is a complicated question. Yes, there is efforts. There's a couple efforts. We are driving a pretty broad effort of how we want MakerBot to interface with all of the Tier 1 CAD vendors. And this all includes MakerBot and Stratasys and the whole Stratasys portfolio, and also how we interface with the low-end CAD vendors. So there should be a seamless workflow across all of those things.
And also in file standardization.
Yes, so file standardization is the next piece. Is there going to be a single 3D printable file to rule them all? I think that's going to be a challenge. Microsoft has a standard, Autodesk has a standard, Stratasys has a standard, and they're all relatively tuned to the hardware. So I don't expect there to be a single printable file format. However, I think everyone in the industry has agreed that STL as a format needs to go away. And so we are working with a consortium of people to make a smooth workflow from CAD that doesn't involve the STL file format. It's limiting, it's computationally expensive, and it doesn't really provide any benefits to the customers.
Right.
Thank you. Do you have any concerns about the possible effects of particulates emitted by 3D printing, particularly on children in the classroom? There is actually a peer-reviewed paper on this issue.
Yes, so we are very well aware of particulates in the classroom and the safety concerns around 3D printing, and I know the paper in particular you're talking about. We've been working very closely with all of the industry certification bodies, OSHA, UL, TUV, all the mainstream certification agencies to honestly and meaningfully assess if there are health risks to these systems and how to address them. So we work with our polymer suppliers to ensure that we're below every nationally recognized health standard inside the classroom. We work with our materials vendors, and we hold our own products to a pretty rigorous testing process to ensure that we are meeting those limits. But the main thing is that we primarily print in PLA, and the MakerBot PLA is an environmentally sound material. It's derived from corn, and it's not subject to the harmful VOCs that you see in some of the ABS printers that exist on the market today.
Right. I think that's the key, right? The fact that we print in PLA makes that subject a lot.
It's a very classroom-friendly material. It's very forgiving and very safe.
Yeah.
Thank you. Do you have plans for disposal or recycling of the discarded components?
Great question.
That's a good one.
Yes, it's a great question. We go through a lot of plastic here at our office in terms of how we print and how we use, and we've actually just piloted an internal recycling program here inside our office, and we're looking at how we can roll that out more broadly. We're also looking at ways to make our spools and all of the other materials that go along with it more environmentally sound. So it's something we're very conscious of. I don't want to see a landfill. I visited a recycling center here in Brooklyn recently, and it really struck close to home how much plastic is produced in this world, and I don't want to be part of that problem. So yes, we are conscious of it and working towards it.
Can you make movable parts, ball and sockets, ball bearings, etc.?
Absolutely, yes. We have a lot of, Jonathan is showing this model here of a jet engine. There are quite a few techniques for making multi-part assemblies in single builds on MakerBots, and we do this routinely here. So a good example would be a hinge or a gearbox. You can print in one build. There's some techniques and some tricks to doing it correctly, but it can be done. You'd be amazed at some of the complex assemblies that we build here. We have that stuff published on our site. I think the question is probably around support material, which we currently don't offer on MakerBot yet, but we do offer a breakaway support structure, a single material support, which works astonishingly well, actually. And you can build these really complex multi-part assemblies, and then once the build is finished, you just snap away these small spindly supports, and your model will move freely. So I recently printed a model of an excavator. It's 6 or 7 parts that build in a single assembly, and no support in that model, actually. So there's some tricks to doing it.
Right, and to spin that off further with the relationship with Stratasys. Stratasys, of course, has soluble support material on its product, and we're collaborating very closely with Stratasys on the material side and on the R&D in general, because there's a lot of benefits to exchanging ideas both ways, by the way, both MakerBot to Stratasys and vice versa. And one of the benefits of doing that is that you can expect some development happening on fronts such as the materials fronts, where, again, I just want to remind everyone on Stratasys they have soluble materials. We don't, but I can share with you that we're doing very close research with Stratasys, so some wonderful things can be expected in the future.
Stratasys has one of the most advanced polymer research centers in the world, I think, on this topic, so we're in a pretty good spot there.
Yeah.
Can you speak regarding the differences in how this technology is applied at various grade levels, K through 12? Are you working with any particular people or groups in elementary education on a nationwide basis?
Yes. So we're seeing an adoption. I mean, you have to remember, this is very, very early. So we're seeing adoption at different levels in different places. One of them is, we see 3D printing clubs in some schools as kind of an after-school activity. But one of the things we're most actively driving is true curriculum for different age groups, right? It's really a K through 5, then a middle school, then a high school curriculum. In K through 5, a lot of it is just explaining the printers and using some very, very basic CAD tools, Tinkercad, or even really just customizing some pre-built models. In middle and high school, it really becomes these more product development track classes where a classroom will do a program around designing a product end-to-end, validating, testing, marketing, the whole thing. The second piece of it is another school we saw recently was a Mission to Mars type of program where they designed everything that went into it was a semester-long or a month-long project where our classroom collaborated to design a bunch of systems that build a Mars base. And each of these systems was prototyped. There was a whole kind of design flow around it and documentation flow, and then they were printed and showed off. I think Jonathan could probably add to this one.
Yeah, I've seen them all. I went to visit. As part of my onboarding here at MakerBot, I did a listening tour. I touched almost 100 customers in 10 weeks. About 80 customers, sorry, in about 8 to 10 weeks, which was fascinating. It was very intense, but it was great. So I definitely saw all the different usages for different, in the educational space. And I agree with Anthony. Whereas, in the K through 12, I think the ecosystem we offer is very interesting. The Thingiverse, the access to Tinkercad that you can then print, convert to STL and print on the MakerBot, and basically some use cases there where teachers are using MakerBot for the purposes of curriculum proofs, mathematical proofs. There's a great model which I love, explaining the Pythagorean theorem through a printed physical object. In biology, there's a great example with a frog where you can actually print in assemblies, and you can dismantle it and ultimately get to the heart of the frog. And again, for teachers, it's very beneficial in explaining how all this is, how the anatomy of the frog is put in place. But then you have more advanced usages. So yes, in the Brooklyn Tech here nearby MakerBot. They're using 3D printing using MakerBots for civil engineering and doing projects there for competition. The last project was using MakerBots for robotics purposes, and then at university for the purposes of research, not research, but doing projects for class activities. And then that's where sort of the innovation center, that's where sort of Thingiverse and the models that we have on the net there are less beneficial for them because they're really designing their own products. We're actually in that space where we do have benefit is, and part of the ecosystem is using GrabCAD, where we have over a community of over 2 to 2.5 million designers. And so that's a much more professionally based platform where designers can exchange ideas on that platform. GrabCAD is a subsidiary of Stratasys as well. So we're not yet tying all that into the ecosystem, but definitely something that we will be planning to do in the future.
In general, though, it's up to MakerBot and partners of MakerBot to provide the right curriculum tools for educators. So we're working that pretty actively now, and you're going to see a lot more of that in the coming weeks and months.
Mm-hmm.
Thank you. The last question, which is for you to think about our speakers, but also for the audience to discuss further, I believe. 3D printers are a great resource for prototyping, but we tend to see students sometimes too reliant on these. How do we find the right balance to enable students to see the appropriate use and to not 3D print a pipe when they can just use it?
That's a great question. Technology it's about appropriate technology, right? And I think it is a little bit reliant on the teachers and the classrooms to drive the correct behavior. When you have a 3D printer, when you have a hammer, everything looks like a nail, right? When you have a 3D printer, which is a machine that can make anything, is the 3D printer the only tool you go to? When I think about the engineers here and how we work, where 3D printing is just a piece of our overall prototyping flow. We have a machine shop, and we have a laser cutter, and an injection molder. All these things fit together, and it's an essential part of product design. And I think it's important for anyone, just because 3D printing is cheap and accessible, doesn't mean it replaces technologies like machining or injection molding. It's about finding the appropriate use, the appropriate technical solution for the problem you're trying to solve. That said, I think the accessibility of 3D printing does lend itself to, it does become the hammer in some of these situations because it's so easy to use and so cheap and so accessible in a way that machine shops aren't. It's not practical for an elementary school to have a full machine shop these days yet. So it's really up to us as educators and us as MakerBot to make sure that people are using technology appropriately and finding the correct fits.
Okay, thank you very much. We'll just stop here, I think. We're very close to the break. I do have a couple of other questions, and I see a few others in the room. So please continue submitting any questions you may be interested in asking. And I hear from Jason that we'll post these questions on our Twitter account. In the meantime, please join me in warmly thanking our speakers for telling us great things about 3D printing.
Thank you all very much. Have a lovely rest of the day. Thank you.